Right, let's have a look at number 3 here. So firstly, we have a diagram that shows us a semicircle with semicircle ACB with center O and radius R. So everywhere I see a R, I just tend to write that on the question just so that I am aware of all the information there. The angle BOC is in radians, is x radians, and it's saying the area of the shaded segment is a quarter of the area of the semicircle. All right, let's have a look. So now, I'm just going to mark on that angle there is going to be pi minus x radians. So I'll just put a C here for radians. So we know that area of the segment is a quarter of the area of the semicircle. Now, let's work out area of a segment. We should remember from our work in radians what the area of a segment is. It should be half r squared theta minus sine theta. That is the area of a segment. Now, if we are working out the area of the segment here, the gray shaded area, my radius is r and my theta is pi minus x. So now the area of that segment is going to become a half r squared. Theta is pi minus x minus sine in brackets pi minus x. And so with this, I get a half r squared pi minus x. Now the thing to remember is if x is acute, sine of pi minus x is the same as sine of x. That is one of the rules about sine of an angle. So here, this is the same as saying sine x. Just to explain to you what I'm talking about, if we work out sine of 30, that's a half, and that is exactly the same as saying sine of 180 minus 30. If you type that in your calculator, you get sine of 150, and that is also a half. So therefore, what we know is that sine of x is the same as sine of pi minus x, and hence I've written that as pi minus x. So now we know what the area of that segment is. We are going to use the statement over here, which says the area of the shaded segment is a quarter of the area of the semicircle. So this is going to be equal to a quarter of the area of a semicircle. So in this case, we know what the area of a circle is. So it's going to end up becoming pi r squared over 4. Not over 4, over 2. So what do we have? We've got half r squared pi minus x minus sine x equals a quarter of the area of a semicircle, which is pi r squared over 2. So now I'm going to get pi r squared over 8 on the right hand side, and I'm going to get half r squared over 2 pi minus x minus sine x. If I cross multiply here, so take the 8 up to the top, I get 4r squared pi minus x minus sine x equals pi r squared. And so now I'm going to expand this bracket in there. So I get 4 pi r squared minus 4r squared x minus 4r squared. Actually, I just thought about making my life slightly easier. What if I divide both sides by 4r squared? If I divide both sides by 4r squared, I get pi minus x minus sine x equals pi r squared over 4r squared. Well, this enables me to cancel r squareds out. So I get pi minus x minus sine x equals pi over 4. And if I make x a subject, i.e. take the minus x over to the right hand side, and take the pi over 4 over to the left hand side, and collect the pi terms together, that's 1 pi minus pi over 4 quarter pi. We're left with 3 pi over 4 minus sine x equals x, which is what the question wanted us to show. So now let's move on to the second part of this question. I'm just going to copy and paste this question down so I can see at the same time. Oops. All right, so we've done part I. Let's have a look at the second part. This equation has one root, verified by calculation that the root lies between 1.5 and 1.3. So to verify something like that, first I'm going to create my f of x. I'll call it my f of x. Let's just say x equals 3 over 4 pi minus sine x. If I bring everything over to the left hand side and define that, make it equal to 0 first. Actually, let's just do that. X minus 3 pi over 4 minus sine x equals 0. Now I'm going to define my f of x as x minus 3 pi over 4 minus sine x. And now I'm going to substitute 1.3 and 1.5 in for x. So f of 1.3, let's have a look at f of 1.3. So calculator. Again, I like storing these values. 1.3 store into a. And now I can type in alpha a minus 3 pi over 4. And of course my calculator had to be in radian mode because x was being measured in radians, minus sine of alpha a. Now press equals and I get minus 2.02. So that's the first bit done. Now, if I scroll up, I can see I put in 1.3 as A. Now I'm going to store 1.5 as A, and hopefully I should see when I substitute 1.5 into that expression, there was a change in sign. So f of 1.5 should should hopefully tell us that this is a positive number. Let's have a look what's happening here. Right, this isn't working. Let me just check something out. Right, so hopefully some of you spotted my mistake or made a mistake rearranging this silly thing. As we can see here, this minus x, when I brought it over to the left-hand side, I left it as minus. So here's my mistake. I'm going to change that to a plus. Change this to a plus here. So as you can see, I'm correcting my work. So you're learning how to identify mistakes. So let's actually go and store that in A. And if I go up here and change this expression on here to a plus for 1.3, I get minus 0.9, minus 0.09. 0.926, and then if I do it again for 1.5, if I store that in A and go up and press equals again, now we can see that there's actually been a change in sign. So plus 0.141. Oh, 0.141. Yeah. So let me just rub this out. Not 0.141. So because of a change in sign, therefore root lies in the interval 1.3 and 1.5. Actually should be a square sort of bracket. Right, okay. So now it's saying use the iterative formula to determine the root, correct to 2 decimal places, give the result of each iteration to 4 decimal places. So now for part 3, we need to use iteration, and as you hopefully remember, this is mainly done through the calculator. So I'm just going to write in xn plus 1 equals 3/4 pi minus sine of xn. I'm going to start off with x0 of 1.3, just because it seems like a sensible place to start. And hopefully we'll see that it converges to the root. So for the first value, we're going to show that x1 equals 3/4 pi minus sine of 1.3. So I'm just showing my working out for the first step, and then after that, I won't need to do that. So here, I'm going to type in 1.3 and press equals. And now that's my most current answer. Once I've got that, I'm going to press AC and set up the iterative formula on my calculator. So 3 pi over 4 minus sine of sine of answer now. Okay. So now I get that x1 is equal to 1.3926 to 4 decimal places. 0.39 26. And then x2 is going to equal 1.3720, 1.3720. So we can see that it is converging to something. It's not going completely off track. X4 is 1.3759. So to 2 decimal places, the last 2 answers are still not the same. So I'm going to continue going once more, probably. 1.3751. So X4 equals 1.3751. And we can see that the last 2 answers converge to the same thing, to 2 decimal places. So the root here, we can say correct to 2 decimal places is 1.38.